question is, 6 charges are placed at corners of a hexagon as shown in the figure. Find the electric field at center O. You have to find the electric field and perpendicular to the plane of the figure as a function of distance x from center O. Okay, so the electric dipole is nothing but a pair of charges which is equal in magnitude but opposite sign. So here the dipoles formed are EB is one pair, okay, and along AD is another pair, equal plus Q minus Q. Similarly along EB it is plus Q minus Q. Then along FC also you have dipole pairs. Okay, so these are the three dipole pairs are formed in this hexagon. Now you have to find out the electric field at this point, okay, center, and perpendicular to this plane you have to find out. Okay, now just we imagine there's a test positive charge here, okay, test charge here, and now you're going to find out the electric field direction. Okay, so when you place a plus Q charge here, this plus Q charge, okay, will, what happens to plus Q will be attracted by this minus Q. So along this direction you have the electric field direction, which is E1. Okay, the dipole moment will be opposite electric field. So this plus Q charge will be attracted by this minus Q. So the electric field will be from O to T. Okay, now due to this dipole pair E and B, this plus Q will be attracted by this minus Q. Okay, so how we get this electric field direction is, you have to draw the electric field direction opposite to the dipole moment. So for this, the dipole moment will be from minus to plus, then electric field direction will be opposite to that. So obviously it is from opposite to dipole moment direction. And when you come to this pair FC, it is from minus Q to plus Q. Okay, it is the dipole moment is from minus Q to plus Q. So the electric field direction will be opposite. So let it be E3. Okay, so opposite to dipole moment you draw the electric field. For this D and A pair, the electric field direction is from positive to negative. Okay, so we put the direction from positive negative. So electric field direction will be from positive charge to negative charge. Okay, remember that alone. So electric field direction will be from positive charge to negative charge. Okay, so now we have three charges and all the electric field E1, E2, okay, all these three electric field will be equal in magnitude. So E1 will be E2 will be equal to E3, then it will be equal to E. Okay, so you have E1, E2 and E3 in this direction. Okay, now you have to find the resultant electric field. So draw the resultant electric field. Okay, so let the resultant electric field be ER. Okay, so now you apply the parallelogram law of vector addition. So you are going to find out the resultant vector ER. So ER will be equal to, okay, just substitute A square plus B square plus 2AB. So between E1 and E3. So E1 square plus E3 square plus 2 into E1 into E3 into cos theta we have to find out. Okay, so 60 degree, it's also 60 degree. So total will be 120 degree. So total is 120 degree. So theta is equal to 120 degree. So we know that E1 is equal to E2 is equal to E3 is equal to E. Okay, so make use of that. Then we'll get E square plus E square. Okay, the 2 times of E1, sorry, E into E, because E1 equal to E3 equal to E. So just replace all E1 and E3 by E, and cos 120 is minus 1 by 2. Cos 120 degree is minus 1 by 2. Minus 1 by 2. Okay, so this 2 gets cancelled. So we'll get E square plus E square will get 2E square. Now minus E square. Okay, so 2E square minus E square is root E square. So which is equal to E. So resultant ER is equal to E. This electric field due to the dipole. Okay, so what is the electric field due to the dipole? Perpendicular to the plane they have asked, right? So the formula is for equatorial point, electric field due to the dipole. Okay, at an equatorial point will be equal to Kp by R, they are given as x, so x cube. This is general formula. So ER equal to E will be equal to Kb by x cube. This is the formula for an electric field due to a dipole at an equatorial point. Okay, and to represent the dipole moment, this opposite of electric field is opposite of that of the dipole moment. You put a negative sign there to represent that the electric field is opposite to the dipole moment. Okay. Okay, next problem is you have to find out the electric charges 2Q and minus 4Q are placed at the corners of an equilateral triangle. Okay, ABC of side L. Okay, so all sides are L. The magnitude of the electric dipole moment of the system. So you have to find out what is P, magnitude of electric dipole moment. So first you have to find out the electric dipole pass. Just pick out the electric dipole's pass. So 2Q, this minus 4Q can be written as minus 2Q, minus 2Q. Okay, minus 2Q is nothing but minus 4Q. So just you can pair this two. Okay, so this forms an, okay, this minus 2Q and this minus 2Q forms one pair. Okay, this forms a one electric dipole pair, and this forms a two pairs. Okay, so this is the first pair and this is the second pair. So two dielectric pairs. And what could be the direction of the dipole moment? From minus to plus. So minus charge to plus charge. Similarly, minus charge to plus charge. Okay, so now combine this. Have the dipole moment, draw the dipole moment vector diagram. Okay, for pair 2 it is from minus 2Q to plus 2Q. Similarly, for this minus 2Q to plus 2Q, you have the other dipole pair. Okay, so both are inclined at some angle. Now you find out the resultant vector. Okay, what could be the resultant vector at this point? So again use the vector addition. Okay, since they are given as an equilateral triangle, okay, so theta will be equal to, okay, have it as 60 degree. Okay, so just substitute here. So root of p square, two vectors, okay, p square plus p square into 2 into p into cos of 60 degree. Okay, here a and b is both the vectors is represented by p vector. Okay, so this is a resultant vector. The resultant vector will be PR. So you'll get root of p square plus p square is 2p square plus 2p square into cos 60 is 1 by 2. So 2 gets cancelled. So we'll get root of 2p square plus p square. So what is root of 2p square plus p square? It is nothing but root of 3p square. So which is equal to root 3 into p. Okay. So we know that p is equal to q into 2 L. Okay. So therefore it is given as, okay, here they are given the distance as L. Okay, so they mentioned the distance between us L. So this is your PR. So this is your resultant dipole moment vector. Now in this you substitute, okay, P is equal to Q into L. Therefore the resultant PR will be equal to root 3 QL. So root 3 QL is option is D. Are you able to get? Just where minus 4q is written in terms of minus 2q and minus 2q, and find out the dipole pass. So form the dipole pass and draw the direction of the dipole moment, then find the resultant vector for the dipole moment, okay, using the parallelogram law of vector addition. So in this question, the dipole moment of 3 charges placed each at a distance a from origin, dipole moment of this configuration will be, okay. So you can write this minus 3q, q they are given. This minus 3q can be written as minus q and minus q. Okay, just you are writing minus 3q as minus q minus q minus q. Okay, now this minus q and this q forms one pair. This minus q and q forms one dipole pair, and this minus q and this q forms another dipole pair. Okay, so you have 3 dipole pairs, minus q, q. So dipole moment direction will be from minus to positive. Okay, let it be P1. And this minus q and q forms a dipole moment pair. Okay, P1. And this minus q and q, both all the pairs are equal magnitude, minus q minus q minus q q minus q q. Okay, equal magnitude but opposite sign, and this forms the dipole moment direction from minus q to q. Okay. Okay. So now if we check this dipole moment direction, this p1 and p1 both are equal but opposite direction. Okay, so both gets cancelled. So you can cancel this both, and the resultant will be only this. We have only this p vector, okay, along your minus j cap direction. Okay, so what is p? P is equal to q into distance between the charges. Here the given distance is a. Okay, so q into 2a into minus j cap is the dipole moment. Answer is q into 2a into minus j cap. Only this p1 alone is existing. This both gets cancelled. Okay. Okay, students. I hope you have understand about electric dipole. Kindly subscribe, like and share with your friends. Thank you.